So last video we learned how to graph these piecewise functions. And today we're going to be looking at the graph and then actually writing the function rule. So writing this function rule here with the domains and the different pieces there. So our last learning target for yesterday was I can graph piecewise functions, and then today we're starting with a graph and then we're going to write, I can write the function rule for these piecewise functions. And again, when it says the rule or the function rule, that just means writing the equation. So let's start with this worksheet, this part of your note worksheet here. And we're going to start with number 5. We're going to be writing the piecewise function rule for this piecewise function graph here. So the first thing I want to do, I'm going to write my success criteria up here. The first thing I want to do is find the domain. So let's look at this function here first, then we'll look at this one, and then we'll look at this one. So let's start here with this first piece. And to find the domain is x values. So I'm looking at my endpoints here. And this endpoint is at -3. And then I see that the graph keeps going on to -infinity. So it's getting the smaller, approaching smaller x values. So that means that x is less than 3. And that is my domain there. Now I need to write the equation of this graph. So first I want to determine what would be the parent function of this graph. So step 2, after finding the domain, we're going to determine the parent function. So I notice that this is a straight line. So that's going to be a linear function. And I know that linear functions follow the form y equals mx plus b. M is the slope and b is the y-intercept. So when you're given a linear function, you need to find the slope and the y-intercept. The m, this is slope, and the y-intercept would be the b there. So let's make a note of that. So if our parent function is linear, find slope and y-intercept. Okay? If linear, find slope and y-intercept. So let's go back and do that. So my slope, I know my slope, if I keep going, this is a positive slope because the line is going upward, and it's going up 1 over 1, up 1 over 1, down 1, left 1, down left 1, left 1. So the slope is 1 over 1, positive 1 over 1. And if I keep continuing up 1 over 1, up 1 over 1, until I hit the y-axis, I can find my b. 1 over 1, up 1 over 1, up 1 over 1. So it hits the y-axis right here at -1. And I did that by using the slope. Now I can put it all together and write my equation of the line. So 1 over 1, that's just 1. So 1x, and then the b is negative 1. 1x minus 1. Or you could just say x minus 1. All right, so that's our first piece. Now let's move on to the second piece, this one right here. So I'm going to go back and I'm going to determine the domain. So that was our first step, determine the domain. So our x values from negative 3 to positive 3. And at negative 3, it's closed, so that's going to be less than or equal to. And then at positive 3, it's open, so that just gets a less than there. Zoom out a little bit here. Okay. So then, after I have my domain, I can determine my parent function. This is the V shape, so that's absolute value. So it follows that f of x equals absolute value of x. That's my parent function there. And then I'm going to look for any transformations. So in an absolute value, to write the equation, you want to look for all the transformations. So I know that my parent function starts at 0, 0. So this one has been translated down 2. So I'll write that down. Down 2. Down 2. And then I'll check my slope real quick. Absolute value should be 1 over 1 if it's not stretched or compressed. 1 over 1, 1 over 1, 1 over 1. So we're good. There's no stretch and no compression. And it didn't move left or right. And it's not reflected because it's opening up. So then I just put that together, and I have absolute value of x minus 2. The down makes a minus 2 on the outside, and then that would be my equation there with this domain here. All right, now I'm going to go to this one. So, oh, we need to write down that success criteria. Hold on. So number 4, if absolute value or quadratic you need to find all transformations. If absolute value or quadratic, find all transformations. So that's how we found that equation. And then let's look at constant. So if it's a constant, we just need to find the y value. If constant, find the y value. So that's what we have here. This would be a constant. We know it's a constant because it's a straight horizontal line. And then my y value, if I continue the straight horizontal line, it's going to cross the y-axis at 4. So my y value is 4. Okay. So this last one was a constant because I knew it was a horizontal line, which makes a constant, and it crosses at 4. And then my domain, let's go back here and find the domain, would be from 3 to 10. And they're both closed circles. So there's my third piece. So now I just need to put it all together in my function rule. So it looks like this. You start with f of x to show that it's a function, and then equals, and you're going to put it together in the fancy bracket. So my first one was x minus 1, and the domain was x less than negative 3. My second equation was absolute value of x minus 2 with the domain negative 3 less than or equal to x less than 3. And my last one was a constant of 4. And then I'll put the domain for that one. So this is my function rule for this piecewise graph. So that would be the last step. Let's write the last step down. Step 6. We're going to put it all together. Put it all together. And you write that as f of x equals, and then your fancy bracket, and then you write your equations with the domains. All right, so that's how you work it out. Let's do some more. Let's do this one here. So I have 3 pieces. 1, 2, 3 pieces. So let's start with the first piece. My domain is, I know this x value here at 2, and it's going on to negative infinity, so that means that x has to be less than 2. And then I see this is an absolute value. So my parent function is absolute value of x. And then I'm going to check for my transformation. So I'm going to start at the origin, and I see that it moves 1, 2, 3, 4, 5 to the right. Oh, left. 5. And then it moved down 1, 2, 3, 4. It's opening upwards, so there's no reflection. Now let me check for a stretch or a compression. So I start at the bottom, and I'm going to find the slope. 1, 2, so up 2 over 1, up 2 over 1. So that's a stretch. Stretch of 2 over 1, or just 2. All right, then I'm going to put it all together. So left 5 would be plus 5. Down 4 would be minus 4 on the outside. And then the stretch of 2 would go in the front there. Okay. So that one's done. Let's go to the second piece. So the second piece is just a point. The domain is at 2, exactly 2. So x equals 2 for the domain there. Okay. And then we'll go back and see what the y value is. The y value is 5, so it's just 5. And that one's done. Okay, last piece. This third one, I notice that that is linear. Parent function, y equals mx plus b for linear. So I need to find the m and the b. So I'm going to find the slope. 1 over 1, 1 over 1. And I see that it's going downward. So that's a negative slope, so negative 1 over 1, negative 1 over 1. Negative 1 over 1 is just negative 1. And now let's find the b. So I'm going to continue with this slope until I hit the y-axis here. Up 1 over 1, up 1 over 1. So the b is at 4, right here. Then I can put it together. So negative 1 x plus 4, which would just be negative x plus 4. And then, oh, I forgot to do the domain. So let's go back and get the domain. So it's at 2 here, and it's going towards positive infinity. So that means it's going to be greater than 2. So x is greater than 2. It's open. Open gets the no or equal to. All right, and then the last step is just to put it all together as a function rule. So you would start with your f of x equals, fancy bracket, and then my first piece, oops, that should be plus 5 minus 4 for x less than 2. And then we had 5 for x equals 2. And then we had negative x plus 4 for x greater than 2. And you are done. Let's do a couple more. So take out this paper, take this back out. And let's do number 2A. Start with A down here. All right. Okay, so I have 1, 2, 3 pieces here. So let's start with our first piece. So I'm going to find my domain. Now notice these are in twos. So -2, -4, -6, -8, and then up to 4, 6, 8. So pay attention to that. So this first domain would be from -5 to -2. Oops, -5 to -2, and they're both closed, okay? That's a -5 there. And then I see that it's a constant, so because of that horizontal line. And then I'll follow it over, and it crosses the y-axis at 7. So that's my rule there, 7. Okay, number 2, let's find the domain. That's -2 to 3. And it's going to be linear. So linear, you need to find the m and the b, mx plus b. So the slope, it's going to be negative. It's going down. So down 1 over 1, down 1 over 1, down 1 over 1. So -1 for the slope. And then it's crossing here at +5. That's the b. That's crosses the y-axis at 5. Then I'll put it together. -1x, or just -x plus 5. Okay, the last piece here is also linear, I see. And my domain is 4 to 6. 4 is open, 6 is closed. Then I need to find my m and my b. Not a lot of room to write here. So my slope looks like up 2 over 1, up 2 over 1. So my slope is 2. That's a positive slope there. So I'm going to continue that the other way so I can find where it crosses my y-axis. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So that's at -3. So that's 2m is 2x minus 3 would be the equation there. And then I'll put that all together to write my function rule. So 7, -5, -2, and then -x plus 5, -2, 3, 2x minus 3, 4, 6. And then that would be the answer there. Okay, let's do one more. Last one. All right, so 1, 2, 3 pieces. So this first piece is linear. My domain, let's see, this is going by ones. That's nice. I like it when it goes by ones. So that's -3 to -2. Open at -2. It's linear, so I need to find my m and my b. This is a negative line, so a negative slope, so down 1 over 1. -1. If I keep going, down 1 over 1, down 1 over 1, I hit the y-axis at 0. So that would just be -x plus 0. So just -x will work. Okay, second one, I'm going to check my domain. So that's from -2 to +1, closed at -2, open at +1, so that gets the less than sign. And this is a constant. I know that because it's a straight line. So I'm looking for that y value. The y value is at 1. So that is just my rule there, 1. And you're done with that piece, and you can move on to the last piece. Again, it's a linear, so I'm looking for slope and y-intercept. And then my domain is from 1 to 2 there, both closed. And then sorry about that. The slope, let's check the slope here. So it's going to go up 1, 2, 3, 4 over 1. So 4 over 1 are just 4. So that's your m. So let's continue that slope to see where the y-intercept is. So it's going to be there at -5. Put it all together. So that's 4x minus 5. And then we would just put all these pieces together to write our rule. So f of x equals -x. And then you would fill in the domain 1. Fill in the domain 4x minus 5. Fill in the domain. All right. I hope that was helpful. Now you're ready to do your homework. So you have 3 homework problems. So yesterday you should have done the front side, these 4 problems on the front. And if you had trouble with that, I did post a video of those problems worked out, so you can watch that. And then, so your homework for tonight is 5, 6, and 7. After you complete these 3 problems, turn this assignment into this assignment in Google Classroom. So this video, where this video is posted, this is where you turn in this whole worksheet, front and back.